Hey, it's Mr. Wesley here with another science demonstration for you today. Today we're going to talk about how you, yes you, can boil water with ice cubes? Yes you can. Let's get started. Okay, here are the materials we need to get started. That is a few ice cubes, depending on how big your jar is. That is a glass cup. You can use any glass cup. I'm using my national championship cup. Go Tigers. And a glass screw top jar. It needs to be glass, and it's about a quarter of the way filled with hot water. It doesn't need to be super duper hot. I just got the hottest that it could get out of my faucet and filled it about a quarter of the way up. All right, hit pause if you need to. Go grab your materials and let's begin. All right, so to do the demonstration, go ahead and take your glass jar, turn it upside down in your glass cup. The glass cup is for two reasons. Number one, it holds it in place so it doesn't move around. I'm not worried about knocking it over. And then start stacking up ice cubes on the top of your glass jar. All right. And after a few moments, as the air starts to cool in the container, come on. There we go. So now that water, it looks like air bubbles are going up through that. Can you see it really well in the video? Yep, that's the effect. So that water is actually boiling. And you'll be wondering, how is that doing what it's doing? Well, there's two ways that it could be happening. Number one, it could be that the air is coming in from outside. Well, in order for that to happen, that means water would have to be dripping out of the bottom of the jar here, and it's not. That's why we put the glass. The bottom of the glass is completely dry. So what's actually happening is the ice cubes, as they cool the air in the container, the particles start to get closer together. And as those particles get closer together, they take up less space than they were before. When they take up less space, that means that there's lower pressure in the container. And that is all it requires for that water to start boiling. Hit it. So you might be wondering, hey, Mr. Wesley, I thought water had to be really, really hot to boil. Yes, in normal pressure conditions it does. But what we're doing is when we cool the air in there, the pressure gets a lot less. So the water can actually boil at a lower temperature than normal. That's why when you see some food packages, they say cooking times may vary based on your altitude. If you live somewhere high in the mountains like in Denver, Colorado, or in Mexico City, water can boil at a lower temperature than at most normal conditions. And that's the conditions that we created here in this glass. The air is a lot cooler than it was when we started, which means that it takes up a lot less space. It has more pressure because of that less space, and the water is able to boil at a lower temperature than normal. So all we had to do was get some hot water out of the faucet, cool the air inside the container, and it was able to actually boil. So there you have it. We boiled water using only ice cubes and warm water. Now, remember that boil means that we were just changing the water from its liquid state into its gas state. And we were able to do that by lowering the pressure inside this container so that it was actually able to boil at a lower temperature than normal conditions. Now, if you were to do this with a plastic container, the walls of the container would collapse and it wouldn't stand up to the low pressure changes. Anyway, if you were able to do this experiment, drop a comment and let me know how it went for you. I hope you enjoyed it, and bye for now.